Welcome back, chemistry fans. Whirlwind tour. We're going to see if we can knock out your homework right before class. Kind of what you do, isn't it? Let's see what we can do here. All right. So we've got a compound now dealing with transition metals. So we're going to try and see if we can maybe figure out how to name these things. Okay. So tin on your periodic table has the symbol SN. I am told that it has a charge of 4. That's what the Roman numeral is. Oxygen is on the periodic table of -2. You can use your periodic table to figure that out. You're going to have to do crisscross applesauce to see that it is a 2 and a 4. However, as we learned last time, you must always reduce these down to their lowest common denominator. So that's your balanced formula for tin 4 oxide. Writing out the name is in reverse. Iron 2O3, we got to crisscross the charges backwards. And what you end up with is iron +3. So the name of this one becomes iron Roman numeral 3 because its charge is crossed backwards. I don't need a Roman numeral for oxygen, but I do because it's binary, put the symbol at the end, IDE. All right. Now you're going to have to go and look up what is the polyatomic nitrite. And what you're going to find is nitrate is NO3 -1. Nitrite is NO2 -1. It's got one less. Aluminum, if you look on the periodic table, has a charge of +3. And now I've found out that nitrate has a charge of -1. You take those two charges, you put them in there like you just don't care. You crisscross them down. Now, we can't put a 3 right next to the 2 because that would be 23. So we have to add parentheses. You still can't read my handwriting. And what that would make it is 3 of the nitrites. Okay, next we've got palladium, Pd +2 with phosphate. You're going to figure out its charge is -3. You crisscross those charges and you get Pd3. And again, we can't put the 4 and the 2 beside each other. That'd be 42. So we have to put parentheses around it. All right, electronegativity is the ability to steal electrons, where ionization is the ability to protect your electrons. Explain the reason for the two trends. Both of the trends on the periodic table point up towards fluorine. So let's take a look at this. So both of our trends say that electronegativity and ionization energy have their largest values, largest amounts with fluorine. Why is this? Well, fluorine does not have a stable octet. It has 7. It's trying to get to its first stable octet. So it wants to steal an electron. Well, that's why its electronegativity is high. Well, why would it also have high protection value? Is because it's so close to a stable octet, it does not want anyone else to steal it. So for the same rational reason, it wants a stable octet, but for different reasons. It's trying to gain a stable octet for electronegativity. It's trying to prevent you from losing an electron so it can still have an opportunity to gain a stable octet. So that takes care of everything that I wish to share with you today about your homework. Thank you very much. I'll talk to you again soon.